Moving slightly. And let's check the mic. Looks like the mic is working. Actually, the speaker is not working. Last time it worked, right? Speaker. Speaker. Inside this computer.
Can take flight screen.
Thank you so much. No problem. Testing, testing, testing. Testing, testing. Okay, thank you, Musa. And then individual like learn the DVDs. But it's like this. It's like 150, 200 like that. Collectivization. Even if it was 6 weeks, That only goes out one way.
It's okay. No matter what, don't worry. I know just the you're not going to use you.
Alright, so here. Alright, you're right.
I know what I just give that. Right, that's how you say.
Then we go to practice. But it's special course not just ours. That's one. Are you welcome? Oh, very nice to meet you. So you're out of quarantine, so that's why.
It's okay.
네. 근데 요새 좀 시간 끌는 거 아니야? 일안 하거든요. 그냥 이게 그냥 일을 하는 편이 아니라서. 애들한테? 바로 먼저 진짜 나 절대 없어. 네. 그래서 내가 다 아니 내 진짜 내 철칙이야. 왜냐면 내 지도 교수님이 나 진짜 너무 안 들어오니 원래는 네. 아니 진짜 그래서 아니 싫어. 그리고 아니 나는 나의 지금 교수님 몇 가지 철칙이 있는데 그러면 다른 일도 다른 일도 한게 우리 학사한테는 절대로 뭐 밥 안 얻어 먹는다. 배우다 나이 어린 사람한테는 밥 안 얻어 먹는다. 그런 게 있거든. 그래서 혹시 감사합니다. 그 토요일 날 이렇게 하는 저번 목요일 그러면 저희도 안 됐어? 잠깐만요. 아, 일이어서 해야지. 나도 그냥 수업을 안 하잖아. 근데 되게 수업 같은 게 되게 해주셨시고요. 수업을 맞아. 하나님. 맞아. 매년 내가 in the rest of the world. Yeah.
Okay, good evening and see you again. First time. What's your name? Kulnoor. Sorry, I also forgot others' name also. Okay, so today we're going to talk about what AI of digital transformation. Today again I'm going to talk most focus about data science, how to digitalize this world with the data science, and also I will introduce some AI algorithms and some applications in the business point of view and management, how to where they are using AI, artificial intelligence, and all other applications. So before we start that, you guys remember that about AI last class? Something? Anything? Anything you guys remember? Just forget all things. What is the AI? No? Forget all? Yeah, so artificial intelligence, that anything they're going to do itself some work. Anything, any machine, they will do intelligently as a human can do any work. That is it. So first, let's see about the digital transformation. How it comes to digital transformation. There is a lot of exponential technologies of fueling this storm. What is this? This is a digital storm surrounding all of us. Means wherever we see all sides of digitalization going on, right? From your class to your business, from your shopping, everything is nowadays digitalization. And those digitalization, transformation, and digital storm is depend on this three things. First, technology, trends, and digital leverage. Technologies are like big data analytics, What about the big data? Have you heard? What about data? Do you guys know data? What is the data? Information. And what is the information? Guys are kind of correct. I'm not saying that wrong. You guys are correct. Information is the data. Data is the information. But more difference if someone asks that what is the difference between data and information? Data.
Information is organized data.
Yes, information is organized data and data is only data that can possible to be anything like in alphabet A to Z. These are the data. And if we say that information, if we from the alphabets we are making my name from there, that is giving the information, right? That is the information. Information created by the data in an organized way, and data can be possible to anything, any data, any single word or single letter, it is a data. Okay. So that is a big data analytics. That is comes to big data. That big data means they are collecting the whole data, whatever the data is generating by the digital systems, digitalizations, they're all collecting the data. They don't care about there is a getting some information or not, but they are just collecting the use of the things. So that is the big data. And after doing the collecting data, after that we analyzing things, analyzing data to making the some informative way. That is going for the big data analytics. So big data analytics is connected by the Internet of Everything. It's also automation of knowledge of work, big data and advanced analytics and social metrics and anything as a services. Whatever services you require that you can collect, you can get the information from the big data, from the data of analysis. Sensor and actuators. This technology, they are sensing, creating the data. Sensors putting the everywhere, we can collect the data from the like weather, we are from the satellite, we are collecting the data, what the information is going, what data is having one particular reason, how to changing those input data. They are using to sensor and actuators. Mobile technology. I don't need to explain this mobile technology. Everyone using to nowadays. From mobile, we are doing banking, we are doing shopping, we are doing everything. So that is also, but that is also is digital transformation with the digital form. The cloud computing. Cloud computing. What is the cloud computing? Forget. Last class I told you. That's why I didn't remember. Tell me, what is cloud computing?
So, take the data on the server that everyone can access.
Server or cloud?
Other cloud and everyone.
Cloud or servers?
It's like
Be specific.
all these. The server is named cloud.
Why we give the name of cloud?
Because I don't know why they the name cloud, but like everyone can access to the data.
So when it's raining, then why is not raining the data? Why raining the water?
I think so.
So the cloud means anything, any information, any data we can access anyway. Anywhere, anyhow we can access those data. That's why they give the name of cloud. Cloud is not fixed that, okay, that cloud is going to be only this region going to be rain. That cloud can be moved all around, right? So that's why we give that name of cloud computing. The data are, there is a big servers they are putting in the some particular region, but those region we can access the data from like some server in the India, but I can access from here. Some server is in Korea, we can access in USA. Some server USA, we can access same information in Europe. So that's information we can access anywhere, anyhow, on ubiquitous form. That's why we give the name is cloud computing, and that cloud is providing to data can be stored, place where we can store our information, our data. So easy access. Like Google Cloud, we have Google Drive. That is also cloud. Google provide you are putting your information on the Google Drive and you can access wherever you want. That is your information in cloud computing, in the cloud. But calculating those informations and those things accessing form, that's why it's giving the name computing, cloud computing. By accessing data from the cloud in the different way, what type of calculation is going on to accessing login ID like Facebook. We have everyone has a Facebook ID. We are putting the ID password anywhere we get to access our Facebook page. So that is also calculating your ID password that you are the right person of accessing your profile or not. That is the calculation. So is giving the computing. Then we have natural user interface. Natural user interface means they provide to naturally where users want to be accessed. They provide to some interface to access the data, access to the digital information to anywhere. Like Google Drive, that is the one interface they are providing in the google.com. When you go put the information, that is google.com website, that is the interface, user interface that you can naturally access the information from there. So that is the user interface. Ubiquitous connectivity. Ubiquitous connectivity, wireless communication, mobile phone, satellite, where we are accessing, where we want to go and just call, internet access there, telecommunications. Those is the mobile ubiquitous connectivity. Ubiquitous means anywhere, anything, and we can access that information. So these are technologies providing to change the trends. The trend is integrating the digital and physical experiences, the internet of everything. That internet can be providing to everything current time, whatever we want, we can access those things. Automation of the knowledge, work, big data, advanced analytics, making our social metrics, like I talk about the Facebook, those things they are providing the connectivity with the society and social platform where you can connect it with the peoples, anything as a services. As a service, anywhere, anything we can access the information or data. So they are changing our lives. Leverage the digitalization, improve the experience, enhance the productivity, find the business models, new business model they can provide it, those things. So that is whole called the digital storm. The title is not looks. So that title is this side page is the digital storm that is coming to or not coming. We are surviving in that storm. We are doing these all things, creating a lot of things digitally. Next, we have to this technology is a new now in core in the business. So technologies is changing to the business work, business style, doing to work style or companies, industries, everything. So how can they do that? That is CapEx, that is technology, moves from the cost to capital. IT spend, that the most incremental investment is in digitally, they're using for the IT. Information technologies are trying to implement each and every places, everywhere. Attackers, the up to 25% of enterprises revenues will be taken by digital attackers. You guys have always heard about our news somewhere is coming and that this attack has happened, that hacking has happened. So that thing is up to 25% of enterprises revenues will be taken by the digital attackers. Adoption of the digital technologies will be varied. So what technology, according adoption of digital technologies, what does this mean? That means how can we adopt to any digital or IT for our perspectives in our field? For like my field is the teaching. How I adopt it? Make the PPT, going online classes, offline classes, that we are adopting according to the applications where we are going to use this type of digitalization or application, changing the digital world. Then robot and artificial intelligence join the workforce. So these are upcoming future that coming to upcoming future also, and this they are also started nowadays. Also, organizations are industries are they are using this type of AI and those applications in their workplaces to be do the automation as much as possible to reduce the workload from the human functions. So this is a developing of digital transformation, digital environment. How to do that? This current business growth requirement is future business augmentation plans. We have taken the stock. There's the internal capabilities, digital opportunities, process, technology, business model, external competitive and scenario, and business environment. We have to check this all to current time, what is going on. And then we change to digital structure to prepare to some all structure according to our applications where we are going to digitalize, where we are going to use this digitalization things. So they have adaptability innovation and changes, create the condition and digital excellence, provide to cross-functional collaborations, and change to digital culture. That is the entrepreneurship mindset, skill development, customer centricity. So what does this digital culture means? What we are planning, like something in some application we are apply digitalization, completely digitalize our system, but there is definitely some chances get into some new thing, even technical technology part or even management sections. So we think about to find out some new entrepreneurship, new ideas to how can we improve our more this technology or this platform. To re-engineer process, there is a digitizing process, deliver unified customer experiences, reviewing the business model, and strategic partner management. And last, we have to this technology. They are creating the ecosystem, artificial intelligence, digital devices, data security. These are the most important things is going to improve. Establish the whole digital transformation. These are the process. Taking the stocks, digital structures, digital culture, re-engineer process, and technology implementations. These are the process of step-by-step process to organize or digitalize any organization or any business. So, for example, 86% of CEOs consider their first priority is if you have trends that will transform the business over the next 5 years. They need to more both guys. They don't need to completely technical guy. They don't need to completely management guy. They need to combination. Who has the management skill also with the technology skills? To what recent technologies. So trends that will transform the business over the next 5 years. They have like technological advances. You can see there is 86% of CEOs wants to be their employee must have both technical experiences, and 69% is looking for the demographic shifts, 58 shift in the global economic power, and 39 for resource scarcity and climate change. 28 is organizations. That is report from the PwC CEO survey report. So, yeah, this is the business of top of mind for the business leaders, and their digital transformation is checking like this. The checking for the organization can't transform to digital unless people do. They have the cultural shift, right skills, central to any digital workplace initiative, increasing the involvement of the employee, community, technology, new technology. They employee, if they don't want to learn new technologies, then they have in no organization gonna be improve themselves. We have that good example like last week I talked about the Nokia one. If their employee is ready to learn new things and adopt new things, new technologies, new management, new culture things, then they have been improved very fast. They have very good growth of the company. 42% of CIOs and hiring plans are research the people with combined technology plus business backgrounds. Things. And most important decision CEOs must take the 2016, they have invested in data science and development of the AI and artificial technologies. Because why they are trying to invest in data science, lot of data is creating currently, but no one in the beginning of technologies, nobody can think to that time they need to code technical guy who can develop the Facebook page or website page or some application based applications in. But nowadays, all things available in internet. What we technical guys need to do, they need to find out the correct data, those data, they do the analysis and can predict the what type of product gonna be customers ask in future. That's why people and CEOs or most of organizations, they concentrating about to the data science, collecting the data, and those data can be used in AI field also, used in blockchain field also, cloud computing field also, any technology field that data is gonna be used. So and recently there's somewhere I read that like say that nowadays or in future data is a fuel. Everyone who has as much as data, they will be going to be a bigger, richer and richer. So that things is last 2 years before 2020 or 20, no, 20 first. From 29 or 28, the Korean government has started dam data project. That is a very huge project, like more than 5,000 billion money they are investing on creating the dam project. They want to create whole Korea as the data supplier from the all over the countries, other countries, not only countries inside of the Korea. Korea government, they create that much dam, that much data they will store, and those data they will provide to other countries who need to those type of applications data. So that Korean government is investing a lot of money for making this data science or data tech related things. Then CIO's challenge is convince to the entire enterprise secure by design. So should be treated as a business priority, like leader embeds the digital first to fast track of transformation. By 2018, there is AI will be incorporated, like half of all application developers by AI is saving the generated by AI enabled efficiencies. There is a 60 billion for the US enterprises itself only. And 29% of the responders identify that IoT industries or IoT initiatives and related machine to machine and telematics project as a new area of spending the year ahead, coming 2 years. So, but now is IoT is also itself generating the data, because IoT means, what is IoT? Internet of Things. What does this mean? Internet of Things. Things connected with internet. If that is connected with internet, that means they generate the data, right? No, no one, right? So that IoT is a initiative and related to machine and telecommunication, telematics projects as the new areas of spending for the area ahead. And by end of 2016, 30% of business will have begun monitoring their information asset, which is fueling of information driven or data driven, like 156 billion in 2016. So you can say that is 4 years old data. Nowadays, how much is going to, I think, 500 billion something, those data. So harness information to change the way to do the business. That is a key point of top of the mind for the business leaders and their digital transformation. They are changing to their culture of work culture and work space this way. Then digital transformation is also saving the cost. That best things they don't want to build. Like if someone have information that all information is the internet, data is available in internet or some particular place, people are knowing or organizations know that they assign that people, okay, you can access the data from there. In starting, what we do that, like people are making the companies are making the printout and go to every each persons and then ask that do the survey, right? Doing the survey things. Nowadays, all data is available. They don't need to go to anyone's. They just collect the data from internet and can do that. So they reduce the cost, print out the cost, and people's moving to cost and all things. So digital transformation is the cost saving perspective priorities. There is a digitization of labor, capital, and multi-factors productivity. The combined annual impact is 1.6 trillion to 2.2 trillion by 2025. So that is a total of US GDP they're gonna reduce plus 6 to 8%. So global IT budget, there's operation 57 and 16% innovations are depending. Technologies are moving faster than enterprises needed to exploit them. Exploit them can be disseminated to the for workforce. So like government of UK, they saved the 63 million of money for the in public spending within the years launched in last 2 years. And by 2018, half of all applications developed will incorporate AI. They have by 2020 increased to 60 billion to saving the government of the US enterprises, access infrastructure, digital literacy, and digital tools. So encouraging workers to participate in the digital economy. these things are provided to digitalization drives down to the cost. The investment in the innovation pay off the efficiency and future ready your workforce through the digital literacy. These are input example to how much cost gonna be reduced based on this digital transformation. Okay. So now digitalization, we have to do the some plan, some structure, some process. There is first planning your strategy and make sure you write it all down. Then we have select the different digital areas you want to engage with, assign priorities. Set the budget on your spend for the various digital areas, but be flexible based on the low and high performance. Determine the various KPIs, performance analysis, investment for the different channels, not only KPIs on the campaign, but also business level. And last, we have to, now second last, that is to make sure everyone in the company is clear about the expectations, thousands of followers are not thousands of clients. And last, we have measurement. How will you measure the various activities? Does it measured by end to end? They are doing to this process, each and specific process they are making, like planning. There are higher management who are doing the planning, that what gonna be, which area, which side we are going to move our company. Second, we have the priorities to select the different digital areas and set the budget, fix the budget, low and high, make the performance checking, testing things, and make sure that everyone, like some companies are giving the advertising on the social media, and so much money in the advertisement in the TV and everywhere. But doesn't matter if someone is like your Facebook profile, this doesn't mean that he is following you. So those things is also similar as in company. If some company products some people, like 1,000 people are followers, so doesn't mean those all 1,000 people are going to be your clients. They are not going to be by that all 1,000 people. And lastly, how will you measure the various activities, and does it measure the end-to-end analysis things? This is the measurement of still internet in 2020. Where is that 60-second internet collection, like 1 minute, there is a 1.3 million login in Facebook, 90 million text sent, YouTube 4.7 million, Google app play, 400,000 apps downloaded. These all applications are people are surrounding in internet, right? 60, these are the only 60 seconds data. So if you can see, like some 1.3 million people are logging in at a one time in a 1 minute, that means how much data they are collecting. Everyone has ID password, everyone is doing the profile observation and all things. So these are the how much data is generating. That is the giving the concept that how much data is generated in a 1 minute. So those data, how can we manage those data? Those data are not all information points, information way, because other people have a different perspective to log in the Facebook. Other people have different perspective, different likes, different things. So those all is in random way. We need to make those things in the meaningful information. So like when Trump was the president, during that time there is a one scandal is happened in UK Analytica company. What they did, they buy the data from the Facebook and they moderate the elections based on the what the people or public are liking, disliking, what type of post they are posting. So those things is, you can see they can affect the whole country's policy, whole country's politics, and who's gonna be president, who's not gonna be president, they can be decided by the data. So data is that much important. So these are the type of data. We have unstructured data. There's data. Now you guys clear the concept about the data, right? Do you know the data? Clear, right? Data means anything. Any digital information, not information, any digital value or letter or anything, that is the data. Right? Making the meaningful those data, that is the information. Second, so they have we have to separate several types of data. One is a structured type, that is the called information also. Structured type data is data that has predefined structure like table, spreadsheet, relational database, those things. Unstructured data, there is a data with no predefined structure, comes in any size or form, cannot be easily stored in the table, blocks, text, image, audio files. Quantitative data, that is numerical and height and weight, those things. Categorical data, they are dividing the data is race, sex, and hair color, space, things. And big data, they have like massive data set or data, the content that contains the greater variety arriving to the increase the value of waiver higher velocity and cannot memory of the single system or single machine. So that much is used, or that is called the big data. Okay. This is the source or format of data types. Data source and format, like most of data format is CSV, XML, SQL, Java, JSON, and protocol, bureaus. This type of format is data is available. Data source, companies, property, proprietary data, APIs, government, academic, web scraping, scrolling, those type of data. Those data has some problems. Like there is a two basic problems is classification and regressions. So assigning something to a discrete set of possibilities, for example, spam, non-spam, Democrat, Republican, blood group, AB, or whatever, predicting that is comes from the classification. We divide some data in the classified that okay, this data is this country is Republican country, this is a Democratic countries, and after that we decide that collecting the data from the what the performance and what the thoughts of the Republican countries people, what is thought of the Democratic peoples. So and then we can make some analysis things. So we divide the data classification. Regression, there is a predicting the numerical values. For example, someone income next year, GDP, stock prices, that can be do that regression, do the predictions based on the existing data. We can predict that what type of possibility is going to be happening in the next few years or next year, those things based on the how much data you are collecting. Next, differences, between the business analytics, business intelligence, or business information and big data and data science. Okay, so business analytics, it is a tool to explore the past data to gain the insight into future business decisions. That is the business analytics. Business intelligence, there is a tools and techniques to turn data into meaningful information. Big data, there are data sets that are so large and complex, traditional data processing applications are inadequate. Data science, there are the tools discovering patterns in large data set. So what we are going to talk about next few more slides, data science. So, but if you can see this analytics, intelligence, data, big data, data science is all the same thing. Business analytics, they have some tools, they analysis, we have predicted things. In data science, we have same thing. We going for regression algorithms. Those things in last class we talked about AI, artificial intelligence algorithms. They have predicted what type of image we are giving to the system. They can predict to us based on the past data, right? Based on the supervised data, what we are already teach them our machine based on that. So these all is the common thing just in the change in the business term, a business perspective way to easy to understand for the peoples. That's why they give them similar other different names. Second, we have big data. The big data has the 5 V's. That is the whole big data is depend on these 5 V's. First, raw data, that is value. That is huge. Raw data means no synchronization, no meanings, nothing, only data collection. We have change over time, that is velocity. We have data types, finding the varieties, data quality, they provide to the veracity and information for the decision making. They're using to the value of the data, what type of data is there. So these are the 5 V's who are whole big data is depend on these 5 V's. Second, now let's talk about data science. Now you can see that data science is combined with AI and machine learning together. Because why we did this? Any idea? Why AI and big data science go together? No? No idea? That is AI
The data.
with the data. Exactly. Whatever we are doing in AI, what we are doing, we're making the robots, we're making the natural language translation things, NLP, we're making to whatever we are going to create. This all is make the decision based on our data, right? That's why is machine learning AI is the complete whole data science and machine learning together. But they have changed, they have divided that some specific application based. The machine learning they're using to some recommended technological field. And data science can be used for the business perspective also and management also. Or sorry, technologies also. So in the machine learning, AI has linguistic, vision, computer vision, language synthesis, sensors, robotics, planning. These are the giving the data. Means all technology related things. Vision, we are talking about the images, we're giving the images, we're giving the videos to computer machines, and they will transform the make the decisions based on the our like. Have you heard about deep fake application? Make a new face and same face to the other people, right? Celebrities, and they are even though they change the voices also. So that type of thing is going to the deep fake is an example of the computer vision, that vision. Linguistic, we have translation. We are using Google, Neighbor, and Papago, those translation applications. They are using for the natural language processing. Sensors, where IoT devices, they have all sensors, and they are creating a lot of data, generating things and providing the information. Robotics, we all talk about robotics and planning to how can we make the automation and similar things to our new technologies. So these are AI, machine learning, like support vector machine, decision tree, Bayesian learning, deep learning, AI, text mining. These are the most focused about technical technology development. How can we make the user-friendly technologies? They can help us. Where data science has given to data preparation, process mining, processing paradigm, visualization, statistics, and experimentations. So these things are algorithms or technical things. They use this data preparation and data for the data science processes, functions. They use and they make the systems, make the new technologies and make the new technical things on whatever we are going to use. Okay. So, what is the difference between the machine learning and data science? Machine learning is develop new individual models and prove the mathematical properties of the models. Those models improve, validate a few relative clean and small data sets. Where data science is explore many models, build that and tune the hybrid, understand the empirical properties of the model, and develop use tools that can be handle the massive data sets. That's the basic difference between data science and machine learning. You can see that machine learning using to the data science and make the new models things. So data science is multidisciplinary field that brings together concepts for the computer science and statistics, machine learning and data analysis to understand and extract insight from the ever increasing amount of data. So they have two paradigms, like first hypothesis driven and data driven. What is the hypothesis? What is hypothesis? is a statistics form, right? Hypothesis. Maybe I will be a president in Korea. It's my hypothesis. It's true, not true, don't care. But that is one hypothesis that I will be in future, I will be in the president of Korea. Okay. So that is the hypothesis making any decision in future, but you don't know that is correct or not. No judgment. No, you don't have any proof that you can prove that this hypothesis is gonna be true. Right? Just assume that I will be do this, I will be a more bigger than the Bill Gates and richest people of the world. It's just in future, it depends on the future. But is my hypothesis for that, what I can do, what I can be access, that is different thing. But make the hypothesis, I will be the bigger, richest people in the earth. So given a problem, that what kind of the data do we need to help solve it? Data driven, there is some things. If I say that I will be a president of Korea, that is not, data driven is not proof, is not possible. You can immediately say that things. Immediately you can make the results. Because you are not Korean, then how can be a Korean president? Similar logic, similar data. So given us some data, what interesting problem can we solve with it, and what can we learn from this data? Those type of data driven is making any decision based on some existing data. Hypothesis, for the hypothesis perspective, we don't need to data. We just make the any assumption, any ideas, whatever we want, we just can speak and we can make that, okay, I will make a more bigger company of the compared to Samsung. Is my hypothesis. I cannot do this. Current situation, if someone is know me, someone see my background, they can know, they can say that no, you cannot, because in future I don't know what is going to be. But in current situation, everybody can say that no, you cannot. Because that is my hypothesis, because behind those data analysis, there is no data. I don't have experience about to generate any company. I don't have any company. Just I'm as a teacher. So I don't have any experience. Then how can I make the bigger than Samsung company? That's the things. That is the hypothesis. Data driven, if I say that, okay, in future I will be the department head of my department. That can be possible based on my performance, based on the experience, that can be possible to do. Be happen based on those things, right? Second, these are the data science types of data science. There is a data science, they have regression, classification, clustering, association analysis, anomaly detection, recommendation engines, deep learning, time series forecasting, text mining, feature element selection, and classification. Let's go one by one. First, classification. Classification, we already talked about that classification, right? Just divide some data based on the democratic, non-democratic, republic, non-republic, those basic data. So description of the classification, they predict if data point belongs in one of predefined classes. The prediction will be based on learning from known data. These are the algorithms we use for the decision tree, neural networks, Bayesian models, induction rules, K nearest neighbor, those things. For example, we have assigning the voters into known buckets by political parties. For example, soccer, moms, bucketing new customers into one of known customers. Regression, there is a predict the numeric target level of data points. The prediction will be based on learning from the data set. For this, we have using the algorithm, linear regression, logistic regression. For example, predicting unemployment rate for the next year, estimating the insurance premium accordingly. Nominally detection, they predict if data point is an outlier compared to the other data points in the data set. Distance data, algorithm for the distance-based, density-based fraud detection in the credit card, network intrusion detection, that security perspectives, this anomaly detection algorithms you're using. Time series predicting the weathers, like predict the value of targeted variable for future time frame based on history values. Exponential smoothing, ARIMA, regression, like sales forecasting, production forecasting, virtual any growth phenomena, and there needs to be a extrapolated. Clustering, making a group things, identify natural cluster within the data set based on inherent properties within the data set, k-means, density-based clustering, database scan, DB scan, that is a finding customer segments in company based on transaction and wave customer call data. And last, association analysis, we have identified relationship within the item set based on transactions, FP growth, a priori, find cross-selling opportunities for the retailer based on the transaction. For example, whenever you go to buy some milk, they recommended that you can buy bread also. That is association, because people know that if they are drink the milk, most probably he gonna be eat the bread also. That is association analysis. Like you watching some YouTube videos, then similar videos are going to recommend by the YouTube. They're using to, okay, you are watching the comedy videos, then they are recommending some other comedies videos. Must be, you can maybe watch, you can like that.
What is the difference between
Classification and clustering. Clustering are making the group, they don't know the divide. Like classification, we have a specific that, okay, this is the male and this is the female. That is classification, is specifically defined. Clustering, we making the group similar way, like human group is there, animals group are there, but in the animal group is a different animals is possible. Human groups are different race peoples are possible. Those things making a group of the based on their race, not based on the specific classification, not based on the specific points, things. Next, we have to the data science applications. So data science application, we have first transaction database, like recommender system, Netflix, fraud detection, security and privacy. Wireless sensor data, there is a smart home real-time monitoring, Internet of Things, text data, social media, they provide to protect, review, consumer satisfaction for Facebook, Twitter, LinkedIn, e-discovery, so on. And software log data, there's automatically troubleshooting, genotype and phenotype data, epic to the 23andMe, patient-centered care, personalized medicine, so on. That is just examples, that type of genotype and phenotype data. Now, data science in action. How can we start? Till that, before going to action, till that, have any questions? All clear? May I ask? Okay. So this online guys is, yeah. Do you have guys any questions? Then you can just type your questions on the chat box. So after the class, I will check it and I can answer your questions. Okay, from the online, all online students talking about it. So 5 minutes break.
Then slide to slide. So, and then but
We couldn't hear your voice well.
Okay, guys. So let's start with the data science action. How to do the actions of data science. So first, the approach there is a performance management, where through the process is define, visualize, often using to data set, that dashboard, and manage to KPIs. Outcome is meet goal and KPI targets. Example is scorecard, public works, statistics, start for the startup kit or startup innovation, startup companies, those things. Evolution is the access of project, program, and policy design or result. Better investment of the resources, better policies, the decisions for the outcomes will come. And this example is evolution of transitional kindergarten example. That is third, policy analysis. The policy analysis is defined and access the alternatives using to a broad range of tools. That is report or memo with the policy or program recommendation, like shape of policies analysis according to organizations, according to your particular things you make the policies, right? Those policies has you need to define and make too easy or access to understand by the others also. Those things. We're talking about that. That one. And third, fourth, we have to open data. Publish the civic data for use by the city and other public. So they can understand that what type of data you are using to improving your organizations and those things. Third, like outcomes will be the easier data sharing and reporting, new tools or services built on the data. And example is adopt a drain. And last, data science is identify insight using to the advanced statistics tied to a service change, smarter work on the ground in real time and see the rest of tech. That's things. That is the whole process of the action of the data science. These are the toolkits of data science in statistical methods, sentiment analysis, time series, multi-level modeling, missing data imputation, data mining, classification, clustering, principal component and factor analysis, in machine learning, A/B testing. These all are the how can we use, how can we predict the data, how can we manage those data. These are different methods or models that you can use some particular according to your applications. For example, if you want to analyze the someone's sentiment, how he's feeling, where which action is doing, when he laugh, how to do the action, when he talk, how much action is doing. All data can be stored with the camera, and those data we can analyze and find out the some specific sentiments. What during the teaching, for example, if this whole class is going to record, right? And during class, when I was talking and what is my gesture of talking and how much time I laugh, how much time I said. So we can predict the how much what is the my sentiment during the whole class time. Those things is be using the sentiment analysis, time series prediction, time series analysis. We have start about based on the previous data, previous time, what is happening in the last year, something in this class. According to that, can predict the what is going to be happening in the next class. That type of things. Or we can predict the weather forecasting, share market forecasting. Like we can predict that like Bitcoin forecasting is going on nowadays. Very huge. What is going? Data mining. We do the mining. What is the mining? What is the mining? What is the meaning of data mining? Sorry? Collecting the data. So that is why we call the mining. We can collect the data collection. Correct. Data collection. But mining data means we have like use of the information, use of the thing is going. We are mine that what the data is related with the which particular applications. Do the some mining things, some particular related application, related data collection. Missing data imputation. What does this mean? Like we have used data. There is some data. For example, if we are going to predict the Samsung share in the next year, what the share about the from January to 2020. So we are collect the data from this 2021 whole data, but we are missing some months. Like for example, we missing to May data we don't have, but we can assume that we can based on the before May. What is that? April, and after May, June. So between that, we can access that. Okay, we have data about the April and June. So we can predict that what possibilities is happening in the May data. What is the stock value in the May month? So that is the data imputation, missing data, because we don't have data about the May season. So April and June data we can analyze and we can predict that, okay, maybe possible the data is this. So that can be do the missing data imputations. Pattern recognition is related with this missing data imputations. Pattern recognition means something pattern is going on with regularly basis. For example, if you see that, okay, January Samsung data or stock market is going high, February high, March high, April high, and after that it's come to May. May we don't have data. Then we started to June. Maybe June is going to not that much high, but it's little bit higher. So we can make the average value and find out those data. So we can check the pattern. Pattern means from the January to April, the data is going to be high of the Samsung stock market. Similar thing in the like we doing the face recognition technology, right? Face looking for the face. This is the host face is going to be recognize that. So those face recognition, what they are doing, like if I give them my picture to train the computer, train the system machine. So when I come to front of camera, they will make the pattern. They may make my picture extraction picture of my face real time and what data they have already. That picture already we trained. So they match the pattern. These are okay. This looks like the same or not. So that is the pattern matching. Something is going on. Survival analysis, A/B testing, propensity, score matching, logistic, multinomial. So these all are methods for the toolkits. We different algorithms for different applications. Based on applications, we can use or we can select their algorithm, their methods to apply in the data science analysis things. Okay. Next, we have the tools. First, statistical methods. Second, we have the tools. We have like languages, programming languages, Python, R, SQL, JavaScript, Node, JavaScript. So many different languages we can use. These are the not limited only these. There is a multiple others languages, programming languages we can use. Data science, like Go language is there, some C, Java, those languages also can be used, but those languages are very complex. Here they mentioned about the simplest one and easiest language we can learn easy way. That's why. Second, we have used this library, Scientific Python, Pandas, Scikit-learn, GPText, OpenNLP, Mouse, and many others libraries. They have two tools we can use with this language, within this language, and can be analyzed those things. Then we have data engineering, profiling, job notices, APIs, optimized data pipelines, optimized data storage, and we use the visualization to D3, JavaScript, Diffie, Jiffy, R, Leaflet, Power BI, and ggplot. These are some applications where we can visualize that what data type of data gonna be referenced. So you guys have a statistics class. Just learn something is statistic. Learn. Statistics, like we are predicting the data. So you can see this type of some graph. They have this is the data of like the stock market value of Samsung, like 50,000. And this is the year, a month, then Feb, March, April, so on. This type of graph, you guys understand, right? That type of graph can be generated. Can we evaluate the data, things, when, what data is going on? So this is called a visualization, data visualization things. So data visualization, that we graphical representation of data analysis, data analyze things, we can represent the graphical way. That those applications are using, like in Excel file, have you create the graph, right? Bar graph, chart graph, pie graph, those things. Those are the data visualization. Those things represent data form and can be, if you don't explain anything, just show the result, then people can understand what is the up and down situations. If I just create this thing and ask that this is the data of the Samsung stock from January to April, they can understand that, okay, in January there is a high, in February is going to low, March has a high, and April is again low, those things. So these are some tools, and they can be used for the data analysis purpose things. And last, we have the user experience research, iterative prototyping, photojournalism, documenting, service blueprint, journey mapping. These are some applications where people are using to different application field to those data analysis and data science applications. Now we're going to talk about we have talked about this is the data toolkits, right? Next, we have talked about data cleaning. What does mean, data cleaning? Data cleaning is the process of turning raw data into the clean and analyzable data set to garbage in, the garbage out, garbage in, garbage out, and make sure that garbage doesn't get put in. What does mean? You can read it, right? These are the alphabets, correct? So these are the data, right? So what does mean now this data cleaning? If I ask that, make it what is the information in this data? What is the meaning? There is a lot of data. There is some information is within this data. Can you clean this? No. What is this? M A D H. First half. My name is of half. My name is. And this half is in this data. So making the clean that we have this much data, we're making the meaningful information from the garbage in this data to be, that is the data cleaning. So data cleaning is process turning raw data into the clean and analyzable data set or meaningful data set of the given from the garbage data. Others data we don't require. We just need to find out organize those data and find it which data is going to be used for our prospective, our applications. And those data we can get it from the data set. We do the cleaning of data. Okay. For error and artifact, there is the information that is lost during the acquisition can never be recovered. For example, power outage, crash the server, and artifacts are the systematic problem that arise the form of the data cleaning process. This problem can be corrected, but we must discover them. Okay, so that is the two problems can be happen during the data cleaning. Its problem is error and artifacts. Error can be maybe during the data cleaning, the data gonna be destroyed. Maybe not, sorry, data not gonna be destroyed. System gonna be crashed. Maybe our system power cut, anything. So that is no data cleaning. So that artifact is the data gonna be corrupt, but we can recover those things. Second, we have to data compatibility in data cleaning. So data compatibility problems arise when merging the data set. Merging the data set means if there is an alphabet and there is a number, and we are merging these two data set, making the more meaningful data. That is the problem. For example, make sure that you are comparing apples to apple, not apple to orange. So main type of conversions, unification, that is the unit, metric to imperial, number, decimal to versus integers, names, John Smith versus Smith John, time and data, dates, Unix and UTC and versus GMT, different time style to writing, date and times, currency type, inflation adjusted and dividends types. Data imputation, that process of dealing with the missing values, the proper methods depend on the type of data we are working with. The general method is draw all records containing the missing data, heuristic based, like make a reasonable guess based on the knowledge of the underlying domain, mean value, fill the missing data with the mean random values, and interpolation, nearest neighbor, that is fill the missing data using two similar data points. For example, I give that this nearest one, April and June, between May, that is the nearest data we can calculate those things. And interpolation used to a method like a linear regression to predict the value of missing data things. That is data imputation. Then we have data cleaner other process, that is the outlier detection. Outlier can interface with the analysis, often arise from the mistakes during the data collections. So it makes the sense to run a sanity check to when you collect those data. Like this data we collect, then we have to check that okay, we are not missing any data. So those miscellaneous like lower casing, removing non-alphanumeric, repairing Unicode, removing unknown characters. So note that when cleaning the data, always maintain both the raw data and clean data version together. Otherwise, sometimes I think you guys are every time is doing something. Like if you are doing the assignment, get the assignment some classes. If you're doing the assignment, then you have one copy of assignment that if you are editing something, right? So that is the same thing. Cleaning a data, always maintain both raw data and clean data. The submission of assignment is different, and when you starting the doing the assignment is different. So there is a two files is always in everywhere in your systems, right? So those things are cleaning data, always maintain both. Raw data should be kept intact and preserved for the future use. Any type of data cleaning analysis should be done on a copy of raw data. Okay. Now I'm going to talk about some statistical things to use in this data science. So it's the process of statistical reasoning. There is an underlying population of possible things we can potentially observe, and only small subset them are actually sampled ideal at random. What this means? Statistical is doing two things. You have populations. What does this mean, population? What's the population of population? How many population in this class? 10. Right. So we have total population data is 10. If someone comes and he wanna check that this class students are understanding properly or not, so they will select randomly any students, and they will ask that what you learned today. Tell is a not tell, that is another thing, but they selected people, that is the sample of the representative of this class, right? Representation of this population. Right? So he is the sample. he or she. That is the sample. So same thing in under we have huge data, so we cannot go to check the one by one everything, right? Huge data. So what we do that we are just take its sample data, randomly select those data and do the analysis thing. What type of features and what type of application are going to do by this data set, this group of data. Those things. So underlying population of possible things we can potentially observe only a small subset of them are actually sampled. Ideally, randomly they are selected and samples. Probability theory describes what properties our sample should have given the properties of the population, but statistical inference allows us to deduce to what the full population is like after analyzing the sample. There is the two things. First, probability theory and statistical inference. What is the probability? You guys study the statistics. Percentage for what? Percentage of behavior, what type of gonna be happen? Like we make the probable value means how much you guys understand this class, about this class. So probability, I just say that okay, probability is 100%. It's not true. Never is 100% gonna be true. So we can analyze it according to covariance, according to variance, differences between your to you, you to you, you to you, you to what the knowledge you are getting according to make the variance things, and we calculate that exact probability is happened, how much probability this class gonna be understand by the students. And statistics, so they mentioned that probability theories describe the properties of sample should have given the properties of population. So the probability, they can explain that what is the possible of samples properties, not talking about the whole data populations properties. Maybe some students can be understand, some students cannot be understand, some students have some other issues. So those things gonna be used for the probability. But statistical inference is allowed to deduce what the full population like we assume that based on the statistical methods, we can inference, we can assume or we can get the information or data that, okay, this much percentage of like 80%, 60%, 50%, 40% understand by this, what I taught today, they understand by the whole class based on that sample prediction. So these are the two different things, probability theory and statistical inference. So that I mentioned that these are the populations, and so checking the probability of this sample and calculating the values of this sample, getting the inference statistics. Right? Sampling from the distribution. It is the sampling from distribution is inverse transform sampling points from the given probability distribution is sometimes necessary to run the simulation or whether your data is particular distributions. So was the sampling from distribution. From distribution means someone is getting to like divided in the class. Like if I go for the online classes, if I ask that they are the distribution that I'm teaching online also and offline also, right? So what is going to be happen? What is percentage to understanding to each other, the offline and online together? So take a sample from offline classes, take a sample from the online classes, and then they will make the decision. So that is the sampling from the distribution, different distributed form, distributed sections. The general technique is called the inverse transform sampling or Smirnov transform things. So first draw a random number like t between 0 to 1, compute the value x such as the CDF equals to the p prediction probability of function of x to x. Fx is the sample of population and x is the whole population. Capital X. So use x is the value of random value drawn from the distribution and described to the function of X whole population values. That's for the whole statistics to use how to do the analysis in this. Now, just going to talk about the data science. What is not data science? Till that we're talking about what is the data science. Now, what is not data science? This service change, academic research is not data science. Small changes, major overhauls and service disruption is not data science. Use existing data and collecting new data mostly is not, collection is not data science. Collecting data, using existing data, those are not data science. So that is the whole concept about data science. Anyone has any question?
Why would major overhauls not be data science?
Why it will be data science? Major how is mentioned that small changes. If small changes, like I mentioned, if something May and talking about the May and April and June, right? We're missing the data from May, right? So we do the, if we go for overhauling means go to more exercising things. But we have there is a small changes. We are predicting the data about the next year data. So we don't require to the small data value. We can assume that okay, that can be possible. So we don't require to do all data science methods and those process to expend our energy and other costs in this overhauling on the whole data science. Okay. Then data science. Yes.
There is a data my concept are here is collecting data,
Collecting new data. If you're using the existing data, so the new data is going to be created by the existing data, right? We are collecting those things.
data mining is not like collecting data.
Data mining is not collecting them. Data mining is we have as doing so in that this is the alphabet, right? There we are mining that I find that the meaningful data is my side of that. We searching on those information that is the data mining.
Data mining is like we take like fresh data from existing data.
Not exact data.
Like I mean not exact. Not all information, but what we
Yeah. Can do. Based on our application, where we are going to use those data. According to that, those data we can use doing the mining. Okay, so next we are going to talk about AI, artificial intelligence, and also we're going to discuss, not discuss, going to show you some applications in the business where they are already starting to using the artificial intelligence applications things. So you guys know this guy? This is Lee Sedol. You know, he's the first to play with the computer of the Go, AlphaGo. The game is Korean game and is a very brainstorming game. So he is the champion, he's the grandmaster of this game, and he fight with that game for the computer generated by the one Google is making that AlphaGo game on online, and he play with that computer. So that computer that mentioned that why I'm showing this guy here, I just showing that how much intelligence computers are. Because this AlphaGo game is a very brainstorming game. Too much brain, similar as a chess, like that things. So that is that game. So, and this guy had the lost in the last moment from that game. And then he is the grandmaster of that game. The worldwide is the #1 player of that game. So he lost that game. So I just mentioned that how much computer is advanced, they are playing that type of intelligence game. So that has happened because of this deep mind. Deep mind means we use to deep learning AI algorithms. So So based on those algorithms that they are using and to improving the system and making those type of games, and they are using to making the robot, like last week we talked about to Sophia, that robot and those things. So that much is advance is possible with the help of AI because of artificial intelligence. So what is the artificial intelligence? There is the engineering of making intelligent machine and program. Inside of this whole artificial intelligence is started in 1950s. Talking about artificial intelligence, the first machine was the Turing machine. So it will 60s, 90s, 80s. From 80s, starting with the machine learning, thinking things. And after from the 2006, they started to deep learning. So artificial intelligence is any machine, is automated machine who works for the as intelligent as much as human. That is the AI. And for the machine learning is ability to learn without being explicitly programmed. We just give that model, and according to those models, they are doing the work for as a human intelligence things. And deep learning is the learning based on the deep neural network. What is function? Neural network. What is comes from? Where is come from? Neural network. That much you can see. There is looks so much complex, right? And it is only 1%, not 1.1% of the human brain. Is that much complex in our human brain. So they are just finding to how can we use that human brain connectivity to in the machines. So they're providing to the more deep learning process, more deep learning models. This is the complete machine learning. As that is the three basic: supervised, unsupervised, and reinforcement learning. So there is a supervised learning has this classification and regression. The classification is the fraud detection, image classification, customer retention, and diagnostics. And regression can be used for the forecasting, prediction, process optimization, and insight of applications. Unsupervised one, they use it for the structure discovery, illustration, feature illustration, meaningful compression, big data visualizations, things. So structure discovery, unsupervised one has dimensionality and reduction and clustering. So that dimensionally reduction, they using to application for the meaningful compression, big data visualization, feature illustration, and structure discovery. And clustering, they use for the recommended system, targeted marketing, customer segmentation, so on. And reinforcement learning, their basic application is real-time decision, game, AI, learning, task, skill acquisition, and robot navigations. Like self-driving car is from the reinforcement learning part. So these are some applications of machine learning, classification of machine learning, and their application of those machine learning methods or models. We can call that those models. So we talk about that supervised learning means we already tell to machine what type of we are going to do, what type of work we are going to do. And then machine doing those work according to getting those data. It's just matching the data, what we are inputting and what we already trained, what we already told them. They are just matching those data and give us to output. Unsupervised learning, we don't say that what computer need to do. We just say that this group looks like a fruits, this group looks like a human, this group looks like an animal. We just tell them, and then machine will be find out what group we are belonging. Those things. After that, we giving the inputs. And reinforcement learning, as we talk about, they are based on the train. We are based on the feedback. Machine do itself. We didn't say anything. What we want, we just say that what we want, and machine will do the process based on our input, and then we just give them feedback. Yes, I want this. If you know, they say no, that is wrong. Then machine again go to X, do those same process, and then it will give to another output. That means go more detail in that things. So there is the first one, machine learning. There is the association learning. As I talk about the association one, like basket analysis, P, Y by X, probability that somebody who buys X also buys the Y, where X and Y are product and services. For example, if someone buys the chips, there is a 0.7% he gonna buy the beer also. So market basket transaction has like bread, milk, bread, diaper, beer, eggs, this so on, that is gonna be recommended or associated with the product your shopping point of view. Next, this is the unsupervised learning. Where, what is this? We have training text, document, image, and sounds. We have labeled that. We didn't say that this is the looks like a lion, this is the looks like a human. We just say that we just give them the images, input, and we just label that these are belongs to animals, these are belong to the other humans. And after that, they do the feature vectors. Feature vectors means they finding to what features we are, like animals, like what type of animals, how to looks like. They classify the features. Their voice, they classify their voice, their looks, their their looks, their color, and all things. They will categorize that. Okay, this is the features. Who has this type of feature? They are animal. They classify to humans. They find that male, female. They say that okay, they have these features. They are belonging to humans. These things, and they are labeled. So when we want to be an output, we just give them our new text, document, image. They have extract the feature, machine extract the feature, the predictive model go to check our existing data, and then you give the output. What we are giving, the what input are they are getting. In supervised one, that training, we have input, supervised learning, we give the training information, desired target, what the we want and what we how to that one is looks like. So they have a supervised learning and give the output. The error is the target output minus actual output. If there is a difference, then it's gonna be error. So then reinforcement learning, they using to the reinforce input, reinforcement system, training the information, evaluation, reward or penalties. And after that, output is the action. So objective is get as much as reward as possible. How this function is going to be work like this. For example, this is the agent. Agent is we are the agent. We are given the feedback or award or whatever penalties. Environment is where that application, that system going to be installed. That is the environment. State is the what condition is going to be current time as an input. Second, and reward is going on. Going to agent, agent will be give the reward, take the action, and it comes back to the action in the environment. Check it, and if what positive response is going to be stored the information. This action I did correct, then is stored. If not, then it's going to be repeat the same action. Other things, you change the actions and do the same input, repeat it again. So there is the S0 is the current state, beginning state. Then it will be the action, you finding the reward. 0, then it's going to be second state, state 1. And after state 1, they will action 1 and change the reward 1. And this way they are going on, working on. Till that when that agent not going to be satisfied, or not going to be say that, okay, that work is done. So this is the reinforcement learning policy. They have what to do, reward, what is the good, value, what is good, because they predict the reward and model what follows the what. So that is the whole policy, reward, value, and model of the environment. So here you can see that again, the environment, group of performance, knowledge based, and learning is going to be this is storing, is repeated things, what knowledge is going to be accessed. So next we have some just example, machine learning versus deep learning. What is the difference? Machine learning and deep learning. What is difference?
Give a command. What is it? That in deep learning, it's like you test it, so like do not follow what is it, like follow the problem itself.
That is the reinforcement. Its definition in is name, deep learning, machine learning. What is the meaning of deep? Go deeper and deeper, right? See, deep, deep. Same thing. In the machine, this is also. Deep learning and machine learning are similar, but just different is in deep learning, we go more deeper. And what is the deeper in here? For example, this is the input, person's input, right? In our machine. And then machine will be analyzed according to their database. And they mention that, okay, this is the human, right? Same input, if we give in the deep learning way, what do the deep learning? Deep learning will be extract the features more deeper. Their hand size, their leg shape, their face, their hairstyle, their eyes, their all things, they're gonna be deeper, deeper, deeper. And find out that okay, this man, this is the human, but its hairstyle is like this, hair is body like this, hand is this shape, hand is that much longer, leg is that much longer. More detailed information. That things. So that is the difference. Those are doing the same thing. But in deep learning, they just say that okay, these are male or human or animal. But in deep learning, they say that that is a human and his looks like his hairstyle. What is the hairstyle? How long? How long is hand, leg, all things. Okay. So let's see the example. This is the we give the input of one room, and we ask that what is this one. So this will be extract handcrafted feature, and it will train the classifier, support vector machine, random forest. Those are the method of algorithm we use, and we mentioned that that is the we ask that it is the outdoor or indoor. So he mentioned that okay, this is the indoor result. Okay, but when you use a machine learning, sorry, deep learning, what they did, they extract the features in this form. First convert the low level features, then go for the mid level features, then high level features and trainable classifier. After that, they match this classifier each section with their trained value, and then he said that okay, it is the inside and it has outdoor. This is the outdoor. No, sorry, this is the indoor. First one they just mentioned that we asked outdoor. He mentioned that yes or no. But in this section, he mentioned that it is indoor. What is the inside of it? Based on our application, based on our what question we are asking. Okay. That is the deep learning. But now, we are talking about how is deep learning going to be do this? Because in the machine learning, they just match the existing result and they may provide that output. But in deep learning, they are doing the feature extraction architecture. Feature extraction means they are going to cut each pixel wise pixel and they will collect those information from there. That we talked about the last week, right? This one. We divide this is the one line is the one pixels of this image. In the 64 cross 64. Then after that, we do the what? Max pooling. Exactly. Then we do the max pooling, and then we do again and again. and later we make the connectivity between these match pooling vectors and those things, and we let us know that what is inside of this room. Living room, bedroom, kitchen, bathroom, outdoor, all things we can explain those things. So this one as one example we had using the convolutional neural network, CNN. That is. So similar, we have to CNN, AlexaNet, Google Net, or so many other models is also there. So VGGNet, so many others, like more than 6, 7 models are there. So those models are just like this one, 1, 2, 3, 4, 5, cross 5 matrix they are creating. Others are some high one is currently ResNet model, residuals network. They using to 16 cross 16. So this type of 16 features they are extracting. So all small features they are extracting and they get it the more better result from deep learning. So these are the deep learning advancement of going on in the AI field. Now we're going to talk about the applications in business point of view where artificial intelligence are using really in this field. For example, application of machine learning. Application of like using social media, defining the sentiment analysis, filtering the spam, etc. Using to transportation, there is safety monitoring, doing the air traffic control. Using financial service, algorithmic trading, portfolio management, fraud detections. In healthcare system, we are using drug discovery, disease diagnosis, and robotic surgery. And e-commerce field, customer support, product recommendation, advertising. And virtual assistant. Those we have already, maybe everyone is a face this virtual assistant. Chatbot, when you type doing the shopping or any website you open, they say that, hi, how can I help you? Those, that is the chatbot. Those are the virtual assistants. Those applications like AI in business. Here, AI-driven personal finance management. To provide knowledge, help customer understand the finances. What is the finance? Insight, the real-time, relevant, actionable, and personalized. The providing to prescribe, prescriptive, the advice, actionable, personalized things, and automated actions acting on behalf of customers. Example, automated savings things. Machine learning application in finance, they're using to security, financial monitoring, fraud detection, investment, prediction, risk management, robo advisory, trade settlement, network security, algorithmic trading, and money laundering preventions. So these are all used to machine learning or artificial intelligence for these in specific finance field. You can see that how much is application that they are working or they are implementing already. Next, we have AI in HR. HR, you know, human resource. And every company has, everywhere has, every organization has HR who are recruiting to their new employees, right? So now they are using the AI to finding to think. Like how they succeeding with the AI in HR, like beginner guide in HR, their recruitment, managing human capital management, employee engagement, learning development, and employee benefits. They are using this application of the one particular organization, the beginners of AI in HR. But how they do this process, that they started from 1990 to 2000, they storing the system records from the employees. And in 2000 to 2012, they are automated storing the information. And from the 2013 to they are started smart HR technology. What is that? They are doing this much. Collect the data, automated from just for the some particular recruitment. They advertise that, okay, I'm gonna be recruit this. So many people are applying. They are collecting those data, then analyze or automated. They are make the fix that, okay, this is the condition, what type of employee we require. They put that boundaries or limit line. And after that, they have shortlisted the half employees, someone is not fulfill that criteria. Then we have draw the inside bottleneck. Then after the analyzing data automated, they will go to see what the data remain, and after that make the decision. Those so much easy to have the employee now. So that is the applications of AI in HR, AI in business. Now we just to talk about to the future and present of AI in business point of view. So both business and artificial intelligence technology companies will move at the fast pace. Nowadays, what we in the business field, what we are doing is struggle to make head and tails the of artificial intelligence services. In future, heavy investment in the becoming artificial literate people. Potentially, enterprise customer says these artificial technology companies are trying to sell me snake oil. They can't even explain to me what they do. But in future, the access change the organization to make as use of new AI technology and many different roles across the organization care about AI, from CEOs to technical lead or to product managers. In AI technology companies, these are about to the business companies. Now, AI technology companies, they have 2 days, their corporate want to know what current business problem and the technologies offered by the AI companies can solve and don't care about the technology itself. But in future, AI companies figure out that they need to speak the language of solving a business problem. They start packaging solution to specific business problem as separate products and branding them to that way. So, for example, nowadays I'm getting some advertisement about to manage your meeting, make the calendars. So they ask me that if I'm connected in my mobile phone, they make it the all calendars, my meetings and all schedules. Whatever I'm getting the email meeting for the Zoom meeting and class meetings and all things, they are updated. So this type of things is going to be automatically done. So the AI companies, on the other hand, just want to talk about their algorithms and how their platform could solve the hundreds of problems. They are just talking now these things. To how to solve, they're just talking that how to solve that this algorithm gonna be this is gonna be this, but they're not talking about the process, but they start working alongside the business to create a unique solution instead of just selling the technology itself being a one part of educator and one part of executor. So these are the both in business point of companies and AI tech or technology companies in the future, current time and future perspectives. Now there is a regulation will impact which areas will get the transform first, AI or business. AI technology will transform the business world by starting to regulatory gray areas like healthcare, agriculture, transportation, logistics, financial services, those things. Strategy will evolve to overcome the difficulties of entering gray areas. First, like startups are making global arbitrage, like healthcare companies going to market in emerging market, then drone companies are experimenting in the least regulated countries. The fly under the radar strategy, some startups are being very careful to stay on safe side of the gray areas to keep a low profile and avoid the regulatory discussion as long as possible. Big companies like Google, Apple, and IBM are seeking out these opportunities because they have resources to be patient and are the most likely to be able to affect the regulatory changes. So their ability to affect the regulation is one of their advantage. So a small company has that type of issues. So startups are considering briefing the up funding earlier than they would have. So to fight an inevitable legal, regulatories are hurdled sooner. So these are some issues of the regulation issues with the startup companies and big companies between. Now, future of AI in business. So the practical side of AI technologies will flourish. Most new entrants will avoid the generic technology solution and instead of have a specific business purpose to which put the AI. The more combination of practical and eccentric. Few years ago, a company like Orbiter Insight would have the SIM for page wait, you are going to use satellites and computer vision algorithm to tell me what the construction growth rate is in China. And now it feels like similar. It's going to be happening already. So researchers will continue doing things that make us stop and say, wait, really, like creating fairy godmother drones to help the ordinary computer vision that detect the subtle signs in PTSD, and autonomous surgical robot that remove the cancerous lesions. Overall, agents will become more eloquent, autonomous system, more pervasive, AI more intelligent, and expect more magic in the years to come. So these are the futures in the going to be used in different applications and different fields, AI and data science also. So just let's going for now application of data science tools for students, and these are the three tools anyone wants to use. They can use it to try. Like software, we're using the Python, it's the simplest language till now, current time. And Python has this so much libraries. You can use it. Those libraries free of the cost, and there is a data. Using those data is like means they are already available. Those data you can access those data and analyze, and you can make it your own decision. What is going on? You can make your own predictions. And yeah, sorry, I forgot. I have advertisement for myself. So these are my two books. One is of Management 4.0, where we talked about to the Industry 4.0, all like which application in the business front to agriculture, to marketing, to every field, how much industrial lies in using to technology, those things. So this is a management perspective, and that book is completely research perspective, how to use the blockchain technology in Industrial 4.0. Next, this is another two books, technical. These three books are technical. One is the Information Security of Intelligent Vehicle Communications, where we are using to these are the this year books from January to till now, this year, and these are the last year books, 2020. So yeah, so these are that is the conference proceeding, and this is my own book. I just write completed published in the this May. That I forgot that May, right? Yeah, that May. That's why I remember that. Okay, so that's all from my side. If you have any questions, so let me know. These are the technical books, so maybe it's not helpful, but that Management 4.0 one, maybe it will be helpful for you as a management perspective. Talking about that, that one is maybe helpful. Till that, if anyone questions, so thank you. That's it. Yeah, if anyone has a question, then email me and you can ask me. Yeah. And now after this, we are going to do some robot experiment. Last week we didn't did that thing, so that one we are going today. Robot, and if we have a time allows, then we go for the drone also. We wait, check it. That is done. Done, right? So we can do for the drone also.
Okay, so our students on Zoom, obviously you won't be able to actually make the robots and so on. But please take a break from now for like 10 minutes, and then I will bring my laptop to just show you what's going to happen in our session, just to give you a peek, and then you can leave the class. Okay, so just have a 10-minute break, and then I will come back in with my laptop.
So I showed up 3 of them in this side and left on this one. Or you want me to
That's
start?
fine. No, that's fine. That's fine.
So that it keeps the balance.
I thought it was very bully, so I was like,
Finally.
it's so cute.
Your children will come back.
Really?
So you close it to fly away.
Really? Wow.
I don't know. Yeah. It's called legal.
Yeah, it's fine.
Here. This robot is one robot. Oh, yeah. This one. You want control? No. I think this one is good base if I also put the downside. This one also we can do this. So put the downside. This remote control. Yeah, remote control.
Wow. This is fun.
Okay, students, so we have some interesting things going on here. So let me show you. No, not
No, why?
oh, so that one's working.
Yeah.
Thank you. Okay, so yeah, we are doing some interesting robot stuff over here. It would have been so much nicer if you guys could be here too. But I'm pretty sure you will have other opportunities too. All right, so thanks, and you guys can log off.
Exactly, right?
So our students in Zoom, your class is over, so you can log off if you want. Okay. Bye-bye.
Thank you.
Bye.
Bye bye.
Bye. Is this one working too?
Yes. We just need the application.
Professor, I have one question.
Uh-huh.
Who created these robots?
Oh, who made the
Students. Students.
students?
Yeah,
Okay. So students in technology department, they made these robots. Yeah, I did already. Yeah, I think we can log off now. All right, guys. Bye.
I was also showing off